Hi friends, welcome to our channel Daily Tech. So in our channel, uh, what we going to explain today is the introduction to trigonometry. This is basically targeted for class 10 students who prefer learning from NCERT as a reference book. So they can take the reference of chapter 8 in the NCERT textbook and get learning. So all the very best for your great learning. So as I said, the agenda for today's video would be Introduction to Trigonometry, which is a chapter 8 of NCERT for class 10. So basically, when we speak about Introduction to Trigonometry, so first thing that comes into our mind, or the basic question that everyone who's learning needs to know is, what do you mean by trigonometry, or what is trigonometry? So the word trigonometry is basically derived from the Greek words uh, trigon and metron. So tri meaning three, gon meaning sides, and then metron meaning measure. So in fact, if you combine all these three words, so that comes together as trigonometry, which means you're learning here in the form of trigonometry the measurements of three-sided figure. So basically, when you talk about a three-sided figure, the first and the only figure that comes into your mind is a triangle. So trigonometry mainly deals with triangle and their measurements. So that you'll get to know, or will learn in our upcoming lectures or slides as we progress. So trigonometry, as I said, is a study of relation between sides and angles of the triangle. So the measurement here includes the sides and angles. So we are going to measure the sides as well as the angles of a three-sided figure, which is triangle. And as a part of this course, or the chapter, we would learn the concepts called trigonometric ratios and trigonometric ratios of some specific angles, which are basically 0, 30, 60, 90, 45, and then trigonometric ratios of complementary angles, trigonometric identities, and then there would be a lecture on the summary, which would summarize all the concepts of learned so far in this chapter. So don't worry if you are not familiar with this terminologies. So basically, as we progress, you'll get to know each and every detailing of the particular concept which we deal with, including the basics or the definitions that are required as and when. So as we progress today in the today's lecture, we'll be learning about this trigonometric ratios. Trigonometric ratios. What is a ratio? So ratio is nothing but you'll have a denominator and a numerator. Okay, so numerator by denominator is a ratio. So ratio is nothing but you are making partition of a thing, or you are dividing a thing with respect to either a fixed quantity. So that will be your denominator. And what forms the numerator is the part of that denominator. I mean, which part is this ratio of that denominator? Denominator is a whole. So which how much part does it constitute, does the ratio constitute, is denoted by your numerator. So here in the trigonometric ratios, we'll deal with triangles as a part of trigonometry. So basically in this chapter we'll only deal with right angle triangles and the ratios of the sides of the right angle triangle with respect to its acute angles. So whenever there is a right angle triangle formed, you will be having two acute angles which are formed simultaneously. So the ratio of the sides of the right angle with respect to the two other acute angles in the right angle triangle is called trigonometric ratios of that particular angle which we are dealing with. So as I said, here we'll be only dealing with right angle triangles. So everyone by now hope they are aware of what is a right angle triangle. And for those who are not aware, no worries. Let me explain it for you. So right angle triangle is a triangle whose one of the angles out of three angles is 90 degree. So in the picture which you see, or the diagram which you see here, this is a right angle triangle. In this, the angle B is called a right angle, which is basically 90 degree, and it is denoted by this symbol. And the other two angles, angle A and angle C, are the acute angles. And why are they called acute angles? Okay, so you all know the basic property of a triangle is the sum of all the angles should be equal to 180 degrees. So when you know that angle B is 90 degrees in a right angle triangle, then the other two angles, angle A or angle C, will definitely be, the sum of these will definitely be less than 90. So any angle which is lesser than 90 will be either angle A, I mean the sum of angle A and angle C, and henceforth this angle A and angle C will form acute angles. So, so with this you'll get, I mean, the trigonometric ratios is nothing but the sides, the ratio of the sides with respect to this acute angles, angle A and angle C. We are not, I mean, B will be our reference since it is a 90-degree angle. And with respect to these angles, angle A and angle C, which are acute angles, will be dealing with the ratio of its sides. So that is what you mean by a trigonometric ratio. And one thing importantly you need to know is, uh, if you are considering here angle A, so the angle which it is formed here is denoted by theta. So you can either name it as angle A, or here if it is angle C, or you can always name it as angle theta. So don't get confused if some of the textbooks which are referring to denotes angle theta instead of A or C, and some may directly deal with angle A and angle C instead of using the term, instead of using the symbol or the denotion theta. So this should be clearly kept in mind that theta is nothing different from your angle A or angle C. It is just a denotion to represent an angle. So in a right angle triangle, you'll have three sides. So the side which is the longest one is the hypotenuse. So here the AC, which is the longest side, is called your hypotenuse. And if you are considering angle A, the side adjacent to angle A, there is a side AB which is adjacent to angle A, and the side which is opposite to angle A is called the opposite side. Similarly, if you are considering angle C as a reference, so AB becomes the side opposite to angle C, and BC becomes the side adjacent to angle C. So with whatever the angle you are taking as a reference, the closest side to that angle is your adjacent side, and the opposite side to that angle is that opposite side, and the other one, which is the longest side, which is basically the opposite of 90 degrees, is always an hypotenuse. So hypotenuse is your longest side. Hope everyone is clear till now. So let me move forward to the next further on this trigonometric ratios. So in a triangle ABC, the ratios which you can define are, some of the important ratios which you can define are sine, cosine, tangent, secant, cosecant, and cotangent. So these six are the primary ratios which you can derive from a right angle triangle, or which you can define from a right angle triangle. So this is the right angle triangle which I am taking as an example. Here, with respect to the angle A itself, I'll explain you these ratios. So when I say sine, so here for your clarification, as I mentioned earlier in the previous slide, that the angle can always be denoted either by theta or by the angle of the which we are referring to, or the acute angle which we are referring to. So here in the left hand side, you will have we will have the definition with respect to the angle alphabet, sine A or sine C, and the right hand side you'll have with the denotion of angle theta. So it will be easy for you to refer and not to get confused and get a clarity on the fact that whether it is denoted by sine theta or sine A or angle C, it is both the same. Just you need to know what is the sine of an angle, cos of an angle, tan of an angle, secant of an angle, cosecant and cotangent of an angle. Ratios will be defined as. So sine theta is nothing but opposite side by hypotenuse. So if you are considering sine A, sine of angle A is nothing but side opposite to angle A, which is BC, by hypotenuse, which is AC. So if you see here, sine of angle A is side opposite to angle A by hypotenuse. So the ratio becomes BC upon AC. Similarly, cosine is nothing but the side adjacent to angle A to the hypotenuse. So the ratio of sine adjacent to angle A to the hypotenuse is called cosine of angle A. So here side adjacent to angle A is nothing but AB, and then hypotenuse is your AC. So cosine of angle A is AB upon AC. And similarly the cosine theta is nothing but your adjacent by hypotenuse. So keep in mind, sine of an angle is opposite by hypotenuse and cosine is adjacent by hypotenuse. So whenever you see this sign in mind, you should remember that it is the opposite side that should be considered, and your hypotenuse will be constant in both sine and cosine. And similarly, when you get the term cosine in mind, you should definitely refer it to adjacent, and then hypotenuse will be your common in both sine and cosine. And the next comes your tangent of theta, which is generally called as tan theta. Tan theta is nothing but your opposite by adjacent. So tan of angle A is nothing but your side opposite to angle A, which is BC, upon side adjacent to angle A, which is AB. So tangent of A is BC upon AB. So BC is your opposite side, and then AB is your adjacent side. And then next comes your secant. Secant is nothing but the secant is nothing but the reciprocal of cosine of angle A. So if you see here, the secant of theta is hypotenuse by adjacent, and as I said, it is the reciprocal of your cosine of theta, which means your cosine theta is what? Adjacent by hypotenuse. So if you reciprocal of this cosine theta is hypotenuse by adjacent, which is nothing but your secant theta. Similarly, cosecant of theta will be your reciprocal of sine of theta. So which is your sine of, what is your sine of theta? Your sine of theta is opposite by hypotenuse. So the reciprocal of this will become hypotenuse upon opposite. So your cosecant theta is hypotenuse upon opposite. So keep in mind here, when you are dealing with sine, cosine and tan, uh, basically sine and cosine, the denominator is always your hypotenuse, and when they're dealing with secant and cosecant, your numerator is always hypotenuse. Okay, and next comes your cot theta or cotangent of theta, which is nothing but the reciprocal of tangent of theta. So now your tangent of theta is opposite by adjacent. The reciprocal of it will become adjacent by opposite, which is nothing but your cot theta. So these six ratios which are mentioned here or which are explained here are very important for you to keep in mind, so that it will be very easy for you to solve the problems, any complex problems based on this simple six ratios. If you keep in mind, it will be basically very easy for you to solve any kind of problem, any complex problem that you get in your examinations. So as I said, you get to know by the terms, try to read multiple times, seeing it, and then write it down, and then try to memorize these things, which will be very important. And these are very important for you to understand. I mean, if you get these all the six ratios, then it will be easy for you to understand the lecture further also. So moving forward, as I said, your tan theta is nothing but, or tan A is nothing but opposite by adjacent. So your opposite side is what? BC, and the adjacent side is what? AB. So BC by AB. So if I divide AC in the numerator and the denominator, so BC upon AC by AB upon AC, then your BC upon AC is nothing but, what is BC here? Your side opposite to the angle A. And what is your AC? Your hypotenuse. So BC upon AC is nothing but opposite by hypotenuse, and your AB upon AC. AB is adjacent and AC is hypotenuse. So AB upon AC is nothing but adjacent by hypotenuse. So from the previous slide, you might be remembering that opposite by hypotenuse is nothing but your sine theta, and then adjacent by hypotenuse is nothing but your cos theta. So tangent theta can also be written as sine theta by cos theta, or tangent A can also be written as sine A upon cos A. So this is very important. You need to keep this in mind, that tan A is nothing but your sine A and cos A. So whenever, if suppose you get a question in your examination where they give you your cosecant theta, cos theta, cosine theta and sine theta, and if they ask you to determine what is the tan theta of that angle, then it is simply the sine upon cosine will give you your tan theta value. Or either the way, they can give you your cosine and then tan, and then ask you to find the value of sine A. So if you remember this equation, tan A is nothing but your sine A upon cos A, then it will be easy for you to get any of the three values if other two are given. Similarly, as you know, as I said, the cotangent of A is nothing but your tangent, reciprocal of tangent of A. So when you said tan A is sine A upon cos A, then the reciprocal of it becomes cos A upon sine A, which is nothing but your cot A. So basically, from the previous slide and the present slide, you should be now clear that trigonometric ratios of an acute angle in a right angle is used to express the relation between either the sides of the angle and also the angle. I mean, the whatever is the angle, the relationship between the angle and the length of its sides is what you get with the help of this trigonometric ratios. You are now completely familiar with What do you mean by trigonometry? What is a right angle triangle? And what are the trigonometric ratios? So hope you all like this video, and in the next video I will deal with or discuss with you few practical examples where you can apply these trigonometric ratios. So today we have dealt with the basic ratios, six basic ratios. What is sine, cosine, tan, cot, and secant and cosecant. So what is the relation between tan, sine and cos, and cot, sine and cos? So these things, and as well as what is a trigonometry, what is the right angle triangle, why it is called a right angle triangle. So these things we have discussed in this video. So hope you like this video. So in the next video, as I said, we'll discuss some few practical examples where you can apply these ratios practically, and also few examples where you can solve and then get the result, and how to solve these examples so that any complex problem that you get in your examinations will be easy for you to solve and understand things. So though this is the video all about, and as I said, so you like this video is what I hope, and maybe I'm useful, or I had done my effort in that, help you out in gaining knowledge. So keep learning, stay healthy and safe. Don't forget to post your comments for any doubts or suggestions that will improve myself, and doubts will improve yours. So, and also don't forget to like, share and subscribe to not to miss out on the latest videos posted. Thank you. Keep supporting. Stay tuned for the next lecture. Thank you so much.